So today we're going to begin our notes on our transformation section. We're going to start with our translations, but by the end of this unit we will have talked about rotations, reflections, and dilations as well. So let's just look at some definitions. A transformation is a way to change the position of a figure. That's a fill-in, so I should see your pencils moving. We're going to talk about 4 types of transformations. The first one, which we'll cover today, is our translation. And then we'll talk about our reflections tomorrow. And then rotation and dilation we'll cover next week. Now, the 3, translation, reflection, rotation, don't change the size of the figure. They just change where it is on the coordinate plane. Reflection and rotation will change its orientation. Like it might start off facing upright and it may end up facing down or rotate it a given number of degrees. Dilation is the only transformation that will change the actual size of a figure, but we'll talk more about that next week. So let's look at some definitions for our 4 types of transformations. Our translation, it slides the figure to a new location. So we just watched a quick video on that, how the shape will stay in the same general direction. The size won't change. It's just going to move up and over, or down and over. Bless you. And in that video, it talked about how the x and the y coordinates, we're going to add or subtract values from the x and y coordinates based on how far up or down, left or right we move these shapes. So that's our focus today, but we're going to go ahead and get these other definitions in there. The reflection is a mirror image of the figure reflected over the x or y axis. So the x or the y axis will be what we call the line of reflection. Our rotation turns the figure clockwise towards the right or counterclockwise towards the left, but the size doesn't change. This year we're just going to rotate it around the origin, 90 degrees, 180 degrees, or 270 degrees. And our dilations, just like I was talking about those pupils being dilated, it's going to make it either larger or smaller. Kind of reminds me of proportions in our similar figures when we take a shape and we make it bigger and the sides are proportionate. So our focus today is translations. A translation, that's the transformation that slides a figure across a plane or through space. Plane just means it's flat, it has no thickness like our coordinate plane. With a translation, all points of a figure move the same distance and the same direction. So it's almost like you picked that shape up and just slid it around the coordinate plane. But everything about the shape, its size, its direction, is staying the same. A translation is a change in location. So what does a translation look like? It's a change in location, so it would be like the smiley face. If it was going to translate from point X to point Y, following the direction of that arrow, just slide right on over. We talked about this Friday, but there are 2 names for the original shape, and it's new, or the shape after it's been translated. You'll hear me call the first shape as the original shape, And the new shape, after it's been translated, we'll call that its image. It's not the real thing, it's the real thing that's been moved to a different location. So original is start. And then after we've moved it, we'll call it the image. Does anybody remember how we mark the image? How you can tell which one is the original one and which one is the translated one? It's a real small mark, you might miss it, and we gave it a name. Yes, sir? Prime. Awesome. And we use like a little apostrophe kind of to show that the image, or it's the image and not the original. And some assignments, they won't tell you which is which. They'll just give you that little mark, that little prime mark, and expect you to know it's marked with one dash. That means it's the image. Speaking of, it is common practice to name shapes using capital letters. It is common practice to name transformed shapes using the same letters with a prime symbol, and that's what we were just talking about. So here's an example. So if I was to call this shape, I'll just put a star in the middle of this one. And I'll put a heart in the middle of this one. Which is the original and which is the image, and how do you know? Because they don't really tell us. Come out and tell us. Yes, sir. The gentleman behind you. Okay, it does show the arrow going right. So which one is the original? The one with the star or the one with the heart? The one with the star. What if it didn't have this arrow? What if they didn't tell you it moved over? There's a little bitty symbol that, yes ma'am? Prime. This little symbol, I'm going to circle it in all four of these vertices. Just in case this arrow isn't there, if you see those marks, you know that's the image. It's not the original. It's the image. It's the prime. So the example shows rectangle ABCD translated to the right 9 units and up 4 units. So it not only went to the right, it also went up. And if I took just one point, we won't look at all the points just yet, but if I just took point A, and I should be able to move it to the right 9 units and up 9 units and end up on A prime. So let's just try that out. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went 9 units to the right, and I'm going to go up 4 units. 1, 2, 3, 4. And there's where A prime is. And all 4 of those points have been translated in the same way. So 9 units up, 4 units over. There's some quick little fill-ins there for the numbers. Let's examine some translations on the coordinate plane. The example shows a triangle ABC. Translate it to the right 6 units. And again, I'm going to circle that prime mark because if on an assignment they don't come out and give you the arrows or tell you which one is the original, that little mark is going to be the only way you know. The original is not marked. It's the original. It doesn't need anything else to show you that it's the original. The image, the one with the prime notations, is the one that's the new, or the shape after it's been translated. To the right 6 units, so we're moving it towards the larger numbers on the number line. We started out over here at -4. We're ended up over here at positive 2, so it's getting bigger. As we move to the right, that's always going to happen. So the original point for point A is negative 4, 5. It did not move up or down, it just went to the right. So your x coordinate, remember we talked about moving to the right, is going to add to our coordinate. Because we moved 6 units right, we could add 6 to all of our x coordinates. Why does y remain unchanged? It started as 5, it ended as a 5. Why didn't y change at all? Yes, ma'am. We're adding the x only. It only moved to the right. It did not move up or down. So 5 stays the same. So if I was to tell you that the x, will you tell me what's the x value for point B? Just the x. Yes, sir? 5. Up, just the x for point B? What's the old one, the original one, I should say? Negative 1. If you add 6 to negative 1, what do you get? 5. So the new x value is going to be 5. The y value stays the same because it doesn't go up or down. And what's our x value for point C? Anyone tell us? Just the x value? It's negative 4. Add 6 to negative 4. You get 2. So our x value is going to be positive 2. Our y value remains unchanged. And there's some fill-ins there. You're going to add 6 just to your x values because you only moved right. You did not move up or down. And notice negative 4 plus 6 is 2. Negative 1 plus 6 is 5. Negative 4 plus 6 is 2. And all of your x values remain, y values remain unchanged. Okay, our next example. Here is our image because of those prime marks. I know it's no longer the original. This is the original, the big O for original. Put a smiley face in there. I know that because it doesn't have any prime marks. So I started up here. I ended down there, down and towards the left. So I know my y value is going to change. I started up here, I ended down here. And I started over here in the positive side. My x's were positive. And then I moved over to the left. Now my x's are negative. So I moved to the left and down. And I'm just going to pick one point. I'll start with point A. And I'm going to count how many times I moved to the left. 1, 2, 3, 4, 5, 6, 7 units left. And 1, 2, 3 units down. And you've got some fill-ins there. So how do we show with math, with addition or subtraction, how do we show a move to the left? How do you show that you move to the left? Look at the number line. As you move to the left of the number line, are your numbers getting smaller or larger? Smaller. Therefore, you are doing what? Subtracting. So if you go to the left, you subtract. You move down. Look at your x-axis. As you move down, what happens to the numbers on the number line? Do you add or subtract? You subtract. So we are subtracting 7 from our x-coordinate and 3 from our y coordinate.